You won't believe it. Uranus and Neptune might not be ice giants, but rocky giants. As we know, there are 8 major planets in our solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Among them, the 4 smaller ones, Mercury, Venus, Earth, and Mars, are rocky planets, and Jupiter, Saturn, Uranus, and Neptune belong to the category of gas giants. Note that calling them gas doesn't mean they're entirely made of gas. It is because these planets don't have a distinct surface. Their atmospheres are extremely thick. In the outer layer, it is mainly gaseous, but in the inner layer, especially at the bottom, the pressure is so high that hydrogen can be liquefied or even turned into a superfluid. In other words, a gas planet is actually more like a continuum that smoothly transitions from gas to liquid and superfluid. So among gas planets, why are Uranus and Neptune further classified as ice giants? Is it just because they're colder? Well, yes and no. Compared to Jupiter and Saturn, Uranus and Neptune are farther from the Sun, so their surface temperatures are indeed lower. But the Icean ice giant doesn't just refer to low temperatures. There is actually ice on them, and it is the main component. But note, the ice here isn't the water ice we usually talk about. It includes a series of compounds, such as water, methane, and ammonia. That is right. Unlike Jupiter and Saturn, which are mainly composed of hydrogen and helium, most of the substances in Uranus and Neptune are actually ices. Although these ices can really solidify into a solid state, because the ice giants are far from the Sun, they mostly exist in a liquid form inside the high-pressure planets. I am sure you are all familiar with the above knowledge. Almost all textbooks write it this way. But recently, in an article soon to be published in the journal Astronomy and Astrophysics, researchers put forward an idea. The classification of Uranus and Neptune as ice giants might be wrong. What is going on? This brings us to how we know about the internal structure of planets. Often, people say in the comment section, scientists haven't even figured out the Earth yet, and they claim to know what other planets' interiors are like. That can't be reliable. You know, this statement makes a lot of sense. Indeed, up to now, humans haven't even drilled through the Earth's crust, let alone the interior. So how do scientists know what these planets' interiors look like? There are currently 2 main ways to study the internal structure of celestial bodies. The first is based on theoretical models. Essentially, this method involves establishing complex mathematical equations to simulate the physical state inside the planet. Scientists will transform known physical laws, such as the law of universal gravitation, the hydrostatic equilibrium equation, and the laws of thermodynamics, into mathematical expressions, and then build a complete model to describe the interior of the planet. Specifically, based on basic parameters of the planet like its mass, volume, and rotation, scientists calculate the density, temperature, pressure, and chemical composition at each point inside the planet by solving a system of equations. The advantage of this method lies in the reliability of its theoretical basis. After all, physical laws are universal throughout the universe. As long as the model is correct and the calculations are accurate, results that conform to physical laws can be obtained. However, this method also has obvious drawbacks. In order to make the equation solvable, a series of assumptions often need to be introduced to simplify the problem. For example, it is often assumed that the interior of the planet is spherically symmetric, the substances are uniformly mixed, and the physical parameters are constant, and so on. Although these assumptions simplify the calculations, they can also cause the results to deviate from the actual situation, just like the classic spherical chicken in a vacuum. The other method is based on observational data. This method mainly infers the internal structure of a planet by analyzing various data of the planet. For example, by measuring the gravitational influence of the planet on surrounding celestial bodies, its internal mass distribution can be deduced. By analyzing the shape and intensity of the magnetic field, the distribution of conductive substances inside the planet can be understood. The advantage of this method is its directness and objectivity, because all conclusions are based on actual observations, avoiding the influence of some subjective assumptions. Of course, it also has its own drawback, the accuracy of the data. It is difficult to measure the data of many distant celestial bodies, and even if measured, it is hard to measure accurately. Sometimes, different observational data may even conflict with each other. Both methods have their pros and cons, and people often verify the results of the 2 methods. For Jupiter and Saturn, it is relatively easier because they're relatively closer to us. More probes have been sent there, and they're mainly composed of hydrogen and helium, with a relatively simple composition. So, we have a relatively clear understanding of the internal structures of these 2 planets. But for Uranus and Neptune, our understanding is still very limited. Labeling them as ice giants is more of a high probability guess. In view of this, This time, the researchers combined the two methods and studied the internal structures of Uranus and Neptune. First, based on theory, they used a computer to randomly generate many possibilities, and then used an iterative algorithm to find those that could match the observational data. The advantage of doing this is to avoid human bias, while allowing the computer to find as many possibilities as possible from relatively accurate data. So, what is the result? It is quite surprising. People found that, besides the possibility that the main components of Uranus and Neptune are ice, there is also a possibility that they are mainly composed of rock. Specifically, for Uranus, the ratio of rock to water varies widely from 0.04 to 3.92. That is, in some models that meet the conditions, the mass of rock inside Uranus could be 4 times that of water. Neptune is relatively better, with this ratio ranging from 0.2 to 1.78. Although it is not as extreme as Uranus, there is still a possibility that there is more rock than water. So, the ice giants we thought they were might actually be more like rocky planets. What is the significance of this discovery? First of all, it changes our understanding of the formation of the solar system. The traditional theory of solar system formation tells us that planets are formed by the condensation of matter in the primordial nebula. The closer to the Sunday, the higher the temperature. Only rocks and metals can condense, thus forming rocky planets like Mercury, Venus, Earth, and Mars. And in places farther from the Sun, the temperature is lower. At this time, hydrogen, helium, and compounds such as water, methane, and ammonia can condense, thus forming gas giants like Jupiter, Saturn, Uranus, and Neptune. But if Uranus and Neptune are really mainly composed of rock, then the previous theory of solar system formation needs to be reconsidered. After all, in places so far from the Sun, the total amount of ice is usually much larger than that of rock. How on Earth did such large rocky planets form? Secondly, this result will also affect the classification of exoplanets. There is a type of planet called mini-Neptune. Although there are none in our solar system, they're very common outside the solar system. Many of them were previously thought to be ocean-covered planets. But as mentioned in the Sooty Planet episode, these planets may actually contain a large amount of refractory organic carbon. So, if our Neptune is really a rocky giant, then those mini-Neptunes may be more like a larger rocky super-Earth. Although this discovery is exciting, many scientists remain cautious. Although both models are consistent with the current observational data, it is hard to say which one is true. In addition, the internal structures of planets may be more complex than we think. They may be neither pure ice giants nor pure rocky giants, but a mixed structure in between. In short, to confirm what the interiors of Uranus and Neptune are really like, we ultimately need more and more accurate observational data. The good news is that NASA is planning a space mission called the Uranus Orbiter and Probe, aiming to conduct an unprecedentedly detailed exploration of Uranus. This will be the first time since the Voyager 2 flew by Uranus in 1986 that humans have explored this mysterious ice giant up close. The plan was originally scheduled to launch in 2031 and is expected to reach Uranus in 2044. But given the current situation of NASA, the outcome may not be so optimistic.